Welcome to the video on how to find a derivative dy dx of a function that involves an inverse trig function. Now remember, we can use the notation for an inverse trig function with the inverse notation or with arc in front of the abbreviation for the trig function. So involved in this, I see arctan of a ratio. So recalling that the derivative of inverse tan of u is equal to u prime over 1 plus u squared, then that also is the derivative of arctan of u. Just a different notation for the exact same concept. So I have that involved in my function as a second factor. And as a first factor, I have 2x cubed. So now to find the derivative, we see that the dependent variable y is on a side by itself. So we'll look at this derivative, but we also notice that the 2x cubed is multiplied to the arctan of 5x squared plus 3. So we are going to have to use the product rule because of that. The derivative we just learned of arctan because of the second factor, and then we're using the chain rule form of it because arctan is acting on an expression 5x squared plus 3. Let's get started. So we have dy dx. Well, that's going to be the derivative of the first factor, 2x cubed, times the second factor, arctan of 5x squared plus 3, and then plus the first factor, 2x cubed, times the derivative of the second factor, arctan of 5x squared plus 3. So now doing those, applying those derivative rules, the derivative of 2x cubed is 6x squared. And then leave that arctan the way it is. And then plus, keep the 2x cubed, and this time multiply by the derivative of arctan of the 5x squared plus 3. So u here is 5x squared plus 3. So we have our fraction. In the numerator is the derivative of what's being acted on. The derivative of 5x squared plus 3 is 10x. That's in the numerator. And in the denominator, it's 1 plus that expression that arctan is acting on, that 5x squared plus 3 squared. So just following our derivative rule for that. Now there's some simplification that we can do with this. We have our dy dx is equal to our 6x squared arctan of 5x squared plus 3, and then plus that 2x cubed is over 1, so that gives me 20x to the fourth in the numerator. And in the denominator, we can square out the 5x squared plus 3. So that gives us 25x to the fourth plus 30x squared plus 9. And then lastly, we can collect like terms in the denominator of that fraction. So dy dx is equal to 6x squared arctan of 5x squared plus 3, and then plus 20x to the fourth over 25x to the fourth plus 30x squared plus 10. And that is our derivative of our function y equal 2x cubed times the arctan of 5x squared plus 3.